Hello, ladies and gentlemen. I am going to talk about the reasons for inefficient SQL performance. We'll check the main reason for inefficient SQL performance: stale or missing optimized statistics, missing access structures, suboptimal execution plan, poorly constructed SQL. So reasons for bad SQL is inaccurate optimizer statistics. Missing access structures is like indexes, materialized view, partitions, incorrect estimates of attributes, cost cardinality, predicate selectivity, poorly constructed SQL, missing join condition which could result in Cartesian product, using union instead of union all when needed. So you can always use union all if you think there won't be any repetitive information. So union is more like a distinct, and union all is all all uh, all rows. If they are unique, then we don't have to worry about it. Hardware related issues is very uncommon, and if you look at this select statement, is select count asterisk from products P, select prod ID average, unit cost, alias AC from cost group by prod ID, where P dot prod ID equal to C dot prod ID, and product list less than 1.5 into asterisk CC. So if you look at the execution plan, is the transformation taking place, uh, they don't worry about it. If this not taking for place, then you will have to rewrite the code. When you look at this particular example, the result set is not changing, stays the same. So this causes a lot of IOs. This query applies functions to join columns restricting index usage. Make the literal match the column type. When you're filtering, you always have left side equal to right side. So do not put functions on the left hand side. If you put functions on the left hand side, indexes cannot be used. Put functions on the right hand side and that's okay. Left hand side and indexes cannot be used. What if I have to use the function? That is the reason Oracle provides what are called function based indexes. So instead of creating a regular index, create an index with this keyword substring function, like to car employee ID, for example. If whatever you're using in the left hand side of your where clause matches with the index definition, index can be used. So we support what are called function based indexes. If you cannot change this query because it changes your result set, then the way to fix it is to create function based index. So when you're going to do a benchmark with the correlated subquery, and if it says 5.8 seconds and then you are going to convert it to inline view, it will say like 0.6 seconds. It makes a huge difference depending on how many rows are there. Always use quotes, even for numbers. It's a big deal, because in order to make it work, Oracle will do a tune up on the left hand side, and the moment it does a tune up, even though you could be searching on a primary key, index is not getting used and would take forever. When you look in the plan, it says 4 table scan, and you may wonder, I'm searching full table scan, and you may wonder, I'm searching on primary key in Oracle, why is it not using the index? So if it's a to-car field, even for numbers, use quotes, because if you're searching on a primary key, index use is guaranteed. But now, because we have to do an implicit conversion, all you have to do is put quotes around it. Index gets used, common mistakes. You really have to understand the operators in a relational database when you join the current account table to the history table, or when you join a product table to the product history. If you are following the business rule, you cannot have product that's current and history at the same time. uh, Not possible. So if you're doing a union just to see how many products your company has sold in the future and currently, to do a union, replacing union with union all will make a big difference in performance, eliminating the whole sort phase. Optimizer, because Oracle Optimizer does what are called transformations. It actually rewrites your code. Oracle has these objects called materialized views. And materialized views are tables which have duplicated the data from your original table in a subset on an aggregate format. These materialized views are not the regular views. This will take space in the database, and it's kind of permanent. And the neat thing about it is you can always refresh it whenever you need it. So what Oracle does when somebody runs an application against the base tables, and when you try to do an aggregate, what Oracle does is it rewrites the from clause. That's called query rewrite. It's not called a transformation. This is a very high level of transformation. So when you do a explain plan, it says from materialized view, not from table. Exadata, this is very popular. Easiest way to understand a query rewrite transformation is what Oracle says. If you're producing a result set from 10 million rows, and I can produce this result set from this table, which is a child of this, but it only has 100,000 concept to the storage level. Exadata. So now storage has its own optimizer, and that optimizer says I'm aware of each and every block that I have, and you're looking for this data, this column, so you can only read from this block. So it basically gives you the block that you're looking for. Not only blocks, we can even give you a partial block, like 1/10 of a block. It's pretty neat. So what those new products do, they basically cut down SQL tuning to a much greater extent, because storage has its own indexing, storage has its own caching, storage has its own filtering and optimizer. So what you're getting back is like partial blocks from all over the place. So that takes you to the next level. There's storage. There are materialized views. What we are talking is basic transformation, converting a correlated subquery into an inline view. And what is the basic transformation if you go a bit higher? Materialized view, query rewrite, a little bit of extreme level storage. Statistics, AWR and ADDM. So it's automatic workload repository, which is AWR, and automatic database diagnostic monitor, that's ADDM. Business run statistics, and the frequency depend upon the type of business. If you're a bank, one run a day may not be enough, and you may change the frequency to run it 5-6 times a day. So we are doing them automatically, and when we do an automatically, we only do it for the tables where the data has changed 5-10% since the last computation. If inline view is better than correlated subquery, Oracle will do it. Why do we do it? Compute automatic statistics, we do it. Gather system stats, we do it. We don't stop there. If you have a license for automatic workload repository, the AWR and ADDM, you can actually basically turn on monitoring on the entire SGA. And what this does is it looks at the SQL that have a lot of pass time. It looks at SQL that have a lot of weights. It looks at SQL that are doing a lot of physical reads. SQL that does a lot of logical reads, and we call that top SQL. Tuning automation. So what we do is we take a snapshot, every one of them, and we store it in your SysOx table space in what is called AWR, Automatic Workload Repository, and you can log in and you can see for every snapshot top sessions, top SQL, and then you can take that top SQL and give it some of our advisors, which are PL SQL packages. One is also SQL Tuning Advisor, one is called SQL Access Advisor. But what do? They basically take the SQL and to try to run it in different possible ways. And if they can find out a way to run it faster, then it will come back and recommend you an index or rebuild an index or make a composite index or create a function-based index or partition your table or create materialized view, rewrite the SQL, compute statistics, anything that has to do with SQL tuning. They can give you suggestions. There is an automation builder also available. Reactive and proactive tuning. It's the English word reactive and proactive. You can easily understand. It's always better to be proactive than reactive. Finding, when you find the problems, finding a solution is very difficult. But if you make sure that it doesn't happen, it's easier. So AWR may come back and tell you, oh, this is a bad SQL, and says run SQL Tuning Advisor, because ADDM doesn't know how to tune it, so it will only give you reports. So automatic database diagnostic model, it can catch up the top stuff, present it all you on an hourly basis, and you can do it 2 hours, 4 hours, or even half an hour. But it's not encouraged to do less than half an hour because of the overhead. We have automation for everything. Sometimes we have turn on tracing, look in the trace file. Sometimes we can just use SQL Plus. If you want GUI, we have a SQL developer. There are $V views, data dictionary that are reports, AWR, ADDM, and the list goes on and on. There are also TKProf, trace sessions, SQL performance analyzer, SQL performance analyzer, SQL reporter, optimizer, SQL statistics, histograms, etc. There are reactive and proactive tunings. Reactive tuning is someone reports me an issue, I look at the problem. Proactive tuning is ADDM. Nobody has called you, but we had already given you a report, what happens in the last one, what is good, what is bad, what you should look at. Statistics, structures, and automation. One other thing that ADDM does, when it picks up top SQL, it gives you what is called a percentage impact report, saying if you fix it, it will have 20% impact or 30% impact. So based on that, you can make a decision and say, I should work on this first and this one I should ignore. So the job is to find out what is top SQL, what is consuming too much of CPU, and all this could be manual. All this could be automated. Rebuilding indexes, if that is good, why don't you go and do it? Computing statistics, if that's good, why don't we go and do it? In Oracle, you can automate all of that. There are a lot of things, flags you can turn on and say, hey Oracle, if you find it, there's more than 3 times, just do it, don't ask me. So you can do manual implementation or you can automate it. So what is important for SQL tuning is statistics, structures, and we can do it manually and we can also do it automatically. Proactive tuning methodology. Simple design is preferred. Data modeling, tables and indexes using views, writing efficient SQL is very important. Cursor sharing using bind variables instead of putting it in quotes. And so that's about it. Thank you so much.